Well, good evening, AP Physics students. Mr. Kirsten coming at you here. Today we're going to talk about how things expand when they heat up. Talking about Chapter 13, problem number 7. So things, when they heat up, they expand. And certain things expand more than other things. So physicists give alpha the term coefficient of linear expansion. And there's a table in your book that lists alphas for a number of different substances. So for instance, the problem we're going to look at today talks about how there's expansion cracks in roads and in concrete. Because here's a list of coefficient of linear expansions, and concrete and brick expand when they heat up. Liquids also, or any solid, expands when it heats up, not just in a linear dimension, but in volume. So both alpha and beta have the SI units of 1 over degrees Celsius. Now the equation that we're going to typically use when discussing the expansion of solids is the change in length of the solid is equal to alpha times the original length times the change in temperature. Notice this is only the amount of the expansion. If I wanted to know what the new length of an object is after heating it up, I would have to do L naught plus delta L to get the overall length. Likewise, the change in volume of a substance is equal to beta times the initial volume times the change in temperature of the object. So alphas and betas can be quite different. You'll see warning signs on gas tanks sometimes that say only fill them about 90% full. Because the beta of the gasoline might be larger than the alpha of the metal tank. And hence, the gasoline, if it were to heat up on a hot day, it would expand more than the container would, which obviously wouldn't be safe. So anyway, that's some of the basics we're going to talk about in this chapter. Your first problem of the chapter talks to you about how many atoms are in so many grams of copper. And a little hint there, remember that 1 AMU, or 1 U, is equal to approximately the mass of 1 proton, or 1 neutron, 1.66 times 10 to the minus 24th kilograms. So use your periodic table and that conversion there for converting atoms to grams and that type of thing. Okay, let's dive into problem number 7. Problem number 7 states that I have a sidewalk, a roadway, and it's made out of concrete, and it wants to know how large the expansion cracks should be. So we've all seen a sidewalk or a road that has expansion cracks. How wide should they be? We're told that the length of one of the slabs of roadway is 12 meters, okay? So that would be the original length. We're told that while the concrete is being laid, the temperature is 20 degrees Celsius, but the temperature could go up to 50 degrees Celsius, or it could go down to minus 30 degrees Celsius. And the question is, how large should the expansion cracks be? So I'm going to use my formula here, delta L equals alpha times L naught times delta T. Now here I can see that delta L should be the width of the expansion crack. If this slab were to expand, it would obviously expand both that way and that way, but so would the slab on the other side. So the total expansion of this guy would be delta L, and half of it would be one way and half of it would be the other way, but we're assuming the other slab would expand too. So our overall expansion that we're looking for the problem is delta L. Now, alpha, according to the table we were just looking at, table 13.1 on page 358, the alpha for brick or concrete is about 12 times 10 to the minus 6. The original length is 12 meters. And then we just need to figure out the change in temperature. Now, notice that this would be the final temperature minus the initial temperature. Now, notice that we're not really concerned about the slab getting too cold. If the slab gets too cold, it will shrink, but we're not really concerned about shrinking because there won't be, they won't expand into each other if they shrink. So the final temperature would just be 50 degrees minus the initial temperature 20. Again, because we just kind of have to worry about these things heating up, not so much about them getting too cold. All right, so if we plug all those numbers in, we get about 0.0043 meters, or the expansion crack should be about 4.3 times 10 to the minus third meters in between the slabs of concrete for our roadway. All right. All right, well, nice work, physics students. For your joke today, a little preview of just one of the shirts I might wear tomorrow. So today is 3/13, March 13th, and who knows, you might see me wearing this tomorrow, being as tomorrow not only is it Pi Day 3/14, but it's also Mr. Einstein's birthday. And notice that Policeman Einstein has a strict speed limit of 186 miles per second. It's not just a good idea, it's the law. Of course, this shirt referring to Einstein's special theory of relativity that he discovered in 1905. Which states that nothing in the universe can travel faster than the speed of light, 3 times 10 to the 8th meters per second, or about 186,000 miles per second. So, happy almost birthday there, Mr. Einstein, and nice work, physics students. We'll see you tomorrow.